Dear students, welcome back in my class of Embedded Systems. We are now in week number 6, and in this week we will discuss state machine diagrams. If you remember, in the last week I briefly explained how you can design a state machine diagram, but in this week, that is in week number 6, I will explain what is a state machine diagram, why we design a state machine diagram, and the terminologies we use for designing a state machine diagram. So here the term state indicates that we want to understand the sequence of event for an object. I will explain all these things in the coming slides in this video lecture, but just I'm giving a brief idea about why we call it a state machine. So here state means we want to analyze the sequence of event for an object, and in order to analyze the sequence of event, we would like to develop a diagram which will explain the sequence of event for an object, and that is why we call it state machine diagram. I have given the aim and objective for this session in the next slide. So here you can see the aim of this session is to understand what is a state machine diagram and why we design a state machine diagram, what kind of benefit we can get by designing a state machine diagram, and we will discuss the terminologies used for designing a state machine diagram. So in order to achieve this aim, I have listed two objectives. So the first objective is what is a state machine diagram. I will explain this in the next slide, and then we will discuss terminologies one by one in this video lecture. So here I have explained what is state machine diagram and why we design a state machine diagram. So a state machine diagram is a model. So we are going to create a model, or in other words we can say that we are going to create a diagram, or we are going to present graphically how an object behaves. So we want to understand the behavior of an object graphically, or with the help of diagram, or with the help of model. Same thing is explained in point number 1. So a state machine diagram is a model, and why we are creating the model? To understand the behavior of an object. We want to understand the behavior of an object. That is why we are intended to develop a state machine diagram. And what is the basis of designing the model? The basis is if you are performing any event, or event means you are performing any action, you are doing any task or any action. So for and this action you are doing for the object, then in order to perform an event from the start point to the end point, we are performing different action. Like if you are starting from this point, then you are moving to this point by performing action A. Then there is one more point here, and you are reaching to this point, this state, by performing action A, and then you are reaching to the end point by performing action 3. So you are performing action A, and after performing action A, you are reaching from state 1 to state 2. And then when you are performing action A2, then you are reaching from state 2 to state 3. And then after completing action 3, you are reaching from state 3 to state 4. So likewise, whenever we are performing any event, so event means you are starting from at some state and then you want to reach to the end state, and in between you are performing a series of actions, and these series of actions are known as transition or actions. So by performing the transition or by performing the action, you are moving from one state to another state, and that is why this point is given. It is used to specify the sequence of event. Sequence of event means action A1, action A2, action A3. So sequence of event you are performing that an object goes through during its lifetime. So the lifetime of object starts from state S1 to state S4, and then what you are doing here, in order to reach from state S1 to state S4, you are performing series of action, that is A1, then A2, then A3, and then you are reaching to state S4. So you can get this information with the help of state machine diagram. That is why we design state machine diagram. So here I have given sorry, here I have given one example. So this is the starting point. So here we have three states. I am calling it state S1, state S2, and state S3. So if you want to reach from this state S1 to state S2, then the action is this. So this is my transition or my action. If you want to reach from state S2 to state S3, then you are performing this action. If you want to reach from state S3 to state S2, then you are performing this action. From state S2 to state S1, then you are performing this action. So you are performing series of actions for this state machine diagram, and it has three different states. And the explanation of this diagram is explained here. Same thing I already explained what we are doing here. So here there is a door, there is a room, and in this room there is a door, and it has three states: opened state S1, closed state S2, and locked state S3. And then we are performing some actions or some transitions. It is given in the next point, and then some examples are given considering some situation, like if the door is closed, then what will happen? If the door is open, then what will happen? So like that it is explained in third and fourth point. So this is all about state machine diagram. So all in all, you need to keep in mind that the state machine diagram is designed to understand, to analyze object behavior, and how it works. It works based on sequence of events or transitions. And it has a lifetime which starts at some state and end at some state. In the next few slides, I will explain the terminologies which we use for the state machine diagram. So here I have explained what is a state. So a state is denoted by a rounded rectangle or circle. So you can use this notation to represent a state, or you can use circle to represent the state. Next is initial and final state. This is, that is filled black circle, that is filled black circle, that is this is filled black circle. It represents initial state. On the other hand, final state is denoted by a circle with dot inside. So this is the outer circle and this circle has a dot, that is this, inside. So it is the final state. And if you want to reach from initial state to the final state, then and you have some state in between, then you need to perform some actions or some transition, and transitions are represented using the arrow. It is explained in the next slide. So this is one state, this is target state, this is my source state, this is target state, and if I want to reach from source state to target state, then I need to perform some action or transition. There is another type of transition which you can use in state machine diagram, and the transition is known as self transition. So if you are creating a diagram, state machine diagram, and you are performing the transition like this, that is self transition. So this is called as self transition. So these are the terminologies which you can use for creating the state machine diagram. In addition to these terminology like start state, initial state, state, simple state, or transition, self transition, there are some other notations also given which you can use for creating the state machine diagram, which we'll discuss in the tutorial session. So in this week I have just one topic to cover, so that is why I am just providing one video lecture on state machine diagram, because we are going to discuss only this topic in this week, and then you will complete one tutorial session. During the tutorial session you will design. In the tutorial session you are going to perform two things. The first one is you are going to work on examples for designing state machine diagram. Why I am giving more stress on this? Because for the coursework 1 you have to design a correct state machine diagram. That is why I want to clarify all the points for designing a state machine diagram, so that you can come up with the correct state machine diagram for the project which you will develop for coursework 1. So this is the first thing you are going to do in this week, in the tutorial session in week number 6. The second thing you will work on is you will be completing a hardware simulation using Arduino kit. So two things you are going to complete. One is this. So this you will complete in the class, and that's it. And then you will implement this. You will prepare the log file for this example for the submission as a weekly task. So that's all from my side in this week. See you in the class.